In this video, we are gonna solve two problems, this problem and this problem from AIME 2 2022, and they are useful for your problem solving for upcoming AMC and also next levels of that for AMC, AIME, USAMO and other levels 2025, 2024, 2023, and so on. Okay, so let's try first this problem. And both problems are number theory problems. Okay, so we want to learn different ideas in number theory. Okay, let's try this one first. Here we have a squared b squared. So when you have a squared and something like this, one way is to consider mods. So idea one, considering modular remainder, and remainder of what number or mod, what is useful here? Mod 4. We know that if we have a mod 4 can be what, or we can also solve it without mod. Let me tell you first, basic solution, solution 1, you say, okay, a is even or odd, a is 2q or a is 2q plus 1. So a squared here is 4q squared, so the remainder when divided by 4 is 0. Here a squared will be what? Will be 2q plus 1 whole squared. First one squared 4q squared plus 2 times first one times second one plus 4q plus second one squared 1 squared, which is 1. So it will be 4k plus 1. So the remainder is 0 or 1 for a squared. Similarly, for b squared, we can say same thing. 1, 2, 3, 4, 5, 6, 7. So the remainder of a squared when divided by 4 is 0, 1. Here for b squared, similarly 0, 1. For 1, 2, 3, 4, 5, 6, 7, you need to only consider last two digits, idea 2. For 4, you should consider only last two digits. So 67, when divided by 4 is what? 64 is multiple of 4, 3, it will be 3. Now, if you consider 0, 0, it will be 0. 0, 1, 1, 1, 0, 1, 1, 1, 2. We cannot reach 3, so contradiction. So there is no answer for A and B in integers. Okay, so we solved this problem by using two ideas. Let me tell you solution 2 by applying mods. Solution 2 is that when you want to calculate this, you say, okay, a mod 4 can be what? 0 plus minus 1 and 2. Minus 1 is 3, okay? You can also write 3. So a squared will be what? Will be 0, 1, 4, which is 0. So 0 and 1. So a squared plus b squared can be what? Here 0, 1, 0, 1 mod 4. 0 plus 0, 0, or 0, 1, 1, or 1, 1, 2. So it cannot be 3. So again, we reach contradiction because 1, 2, 3, 4, 5, 6, 7. Mod 3 is 67, which is 3. Okay, so we've solved this problem with two ways. Now, let's try AIME 2 2022. Pause the video and try this part first on your own. Find the number of positive integers n, which is less than or equal to 600, whose value can be uniquely determined when the values of n over 4, floor of that, and floor of n over 5, and floor of n over 6 are given, where floor of x denotes the greatest integer less than or equal to the real number x. Okay, let's check and see problem means what. Let's check n1, so idea 3, considering a small example, which is so much powerful. But it's important to get good at this idea, so much useful in AIME, AMC, USAMO, USAJMO, IMO, considering small examples. So here, let's consider the values of floor of n over 4, floor of n over 5, floor of n over 6. If we check for n1, let's write also n here, so n1, it will be 0, 0, 0. For n2, it will be 0, 0, 0. So it will be bad, n1 and 2, because if you see 0, 0, 0, you don't know it is 1 or 2. So they are bad. If n is 3, it will be again 0, 0, 0. It's not good. If n is 4, it will be 1, 0, 0. And 4 is good or not? We don't know. We should check next one. If next one is 1, 0, 0, again, and 4 also is not good. And 5, it will be 1, 1, 0. So n4 is good because we have only one case that has 1, 0, 0. Okay? So if you see 1, 0, 0, we know it is only for 4. What about 6? It will be what? It will be 1, 1, 1. So we can conclude which number is good? 5, because previous one and next one are not equal, and we know in the future we cannot see. In the rest of the numbers, we cannot see this one. Again, because these numbers are increasing, not strictly increasing, but we can say or non-decreasing. Okay, n6, let's continue. n7, n over 4 is 0, n over 5, oh sorry, n over 4 is 1, n over 5 is 1, n over 6 is 1, so these two numbers are bad. For n8, n over 2 is, n over 4 is 2, n over 5 is 1, n over 6 is 1. We should check next one to see 8 is good or not. If you check 9, 9 over 4 is 2, 9 over 5 is 1, 9 over 6 is 1, so these numbers are not good. 10. 10 over 4 is 2, 10 over 5 is 2, 10 over 6 is 1. So we should check next number to see and 10 is good or not. 11. 11 over 4 is 2. 11 over 5 is 2. 11 over 3, 11 over 4, 5, 6 is 1. Again, these numbers are not good. What about 12? Let's find next good number. Pause the video and try to find next good number. 12 over 4 is 3. 12 over 5 is 2. 12 over 6 is 2. 13. 13 over 4 is 3. 13 over 4, 5 is 2. 13 over 6 is 2. 14. 14 over 4 is 3. 14 over 5 is 2. 14 over 6 is 2. They are bad numbers. 15. 15 over 4 is 3. 15 over 5 is 3. 15 over 6 is 2. Next one, 16. 16 over 4 is 4. 16 over 5 is 3. 16 over 6 is 2. So this one is good because it is not equal to previous one, 2, 3. We have one increment here, plus 1, and we have 1 here, plus 1. So because of this, we can say this number is good, okay? So now we want to generalize this idea. A number is good under what case? N is good if, for example, it is x, y, z, then n minus 1 and n plus 1 should be different. For example, we should consider different cases. This one, x minus 1, we have one increment here. This one, y plus 1, we have one increment here. And we said these numbers are for what? N over 4, n over 5. It was one case. Maybe plus 1 here should be, for example, here we have z minus 1. We should consider different cases and see n should be what. So try to pause the video and try to consider different cases. Okay, now let me explain something. Here, when 15 is good, when we have increment here, it means what? For example, for n over 5. It is related to n over 5. Here, when it is 2, it is 3 next number, it should be multiple of 5. Okay, so because 14 over 5 is what? 14 over 5 is 2 point something. Okay, 2 points we can say 3 over 4 over 5, which is 2.8. And it will be 2. But when we have 15 over 5, it will be 3. And we have a jump in floor. Okay, 2 to 3. So when 15 is good and we have increment here, this one should be multiple of 5. And when we have increment here, it should be because it is related to n over 4. Floor of that, 16 should be, means here n minus 1, n plus 1. 16, which is n plus 1, is multiple of 4 because of increment here. N should be multiple of 5. And we should consider different cases. 4, 5, 4, 6, 5, 6. Okay. Now here we should use case word. Idea, it will be idea 4. Idea 4, case word. Means what? Case 1. Let's consider this one as case 1. It means let's consider this and we will write other cases. Here, because it is related to n over 4, we can conclude n should be multiple of 4. Okay? So n mod 4, if we can write mod 4, mod 5, mod 6. So for this case, n should be multiple of 4 because of increment here. And for this one, n plus 1 should be multiple of 5 because we have increment here. When n plus 1, mod 5 is 0, so we can conclude n is what? If you subtract 1 from both sides, n mod 5 is negative 1. Okay? So we have 0, negative 1. If we write other cases, case 2, 0, negative 1. If 0 is here, 0, negative 1. 0, negative 1, 0, negative 1, and 0, negative 1. Okay, so we have 6 cases. Now we want to consider these 6 cases to see that which n satisfy, and we know n is positive integer from 1 to 600. We should find all n's from 1 to 600 that satisfy at least one of these conditions. Try this part first on your own. Let me show you how to solve one of them. We have 6 cases. For example, 4, 0, mod 5, negative 1. We have 2 solutions for solving this. For example, this one. Let me show you. N mod 4 is 0. And n mod 5 is negative 1. Okay? Mod 4, mod 5. Can you guess we can find when we know a number mod 4 and mod 5, we can find mod what? We can find mod LCM, which is mod 20. And how we can find? Here you can add 4. For example, it is 0, 0 mod 5 is 0. If you add 4, 4 mod 5 is negative 1. So because 4 satisfies both of them, we can write 4. Okay, one easy way and here useful is this approach. So let me write idea 5. We have also another idea, especially for large number, it's useful. When it is 0 mod 4 and negative 1 mod 5, we can write n is 4k, and then you replace here, you say, okay, 4k for example is negative 1 mod 5. Then 4 is what? Is negative 1 mod 5. Negative k you multiply by negative 1, k is 1 mod 5. So we can conclude k is 5q plus 1. If we replace here, n is 4 times this, which is 20q plus 4. So n mod 20 is 4. Okay, 2 approaches. Approach related to idea 5, I think is easier here. Okay, so we've solved this one. For this part, we can conclude, let me move it here. For this one, we can say mod 20, it should be 4. Now work on second, third, fourth, fifth, and sixth case. First on your own. Okay, so second case, 0, negative 1. Because mod 4 is 0, it is 4k, so it is even. Okay, because of this, it is. When mod 6 is negative 1, it means that it is 6k minus 1, which is odd. So that's the contradiction, because it cannot be both even and odd. We can also reject this case, because it is 4k minus 1 odd, 6k or 6q even. This case also contradiction. Now focus on third, fourth, and sixth case. For third case, negative 1 for 5, 0. Let's check. Mod 4. Negative 1, mod 5, 0. So if we add 5 to this one, because 0 mod 4 is 0, 5 mod 4 is 1. 10 mod 4 is 2. 15 mod 4 is -1 because it's 3 or -1. So we can conclude mod. And mod what? LCM of 4 and 5. Mod 20, it will be 15. Now for this case. 5, 0, 6, -1. So we can write right here mod 30, 0, -1. If we consider 5, 5 is 0 mod 5, 5 is -1 mod 6, so it will be good. And this one again for 5, 6 mod 30. So 0 mod 5 is 0, not possible. You add 6 like this. 6 mod 5 is 1. 12 mod 5 is 2. 18 mod 5 is 3. 24 mod 5 is 4 or -1. So mod 30, 24. So we have these 4 cases. Let's write mod. Let me write with pink mod 20. 4 or 15. Mod 30, 5 or 24. Okay. From 1 to 60, we should see how many cases are there, and we should subtract intersections. Okay, so pause the video and try the rest first on your own. Okay, if we calculate intersections, mod 20, for example, n is 4 mod 20, and mod 30 is what? 5 is not possible because when it is 4, it is 20k plus 4. Look, when it is 20k plus 4, it is even. Why? Because you can factor from 2, it's 10k plus 2. But when it is 30k plus 5, it's odd because it is 2 times 15k plus 2 plus 1. 2 times 2, 4 plus 1, 5. It is odd, it is even. So this one shows that n is even, this one odd, this one odd, this one even. So the only possible case for intersection is even, so 4, and for next one, 24 mod 30, 424 or 15.5. So for this case, if we check 24, 24 satisfies this one for mod 20. So n is 24 mod LCM. LCM of 20 and 30 is what? Is 60. Okay, so one intersection is this. Next one, n is 15 mod 20, and n is 5 this case. 5 mod 30. So 20, 15 mod 30 is not 5. If we add 20, 35. 35 is 5 mod 30. So n is 35 mod 60. Now, let's calculate. Let's see the answer is what. Okay, so first here, mod 20 is 4 or 50, and it's from 1 to 60, okay? Or 1 to 600. For this one, because 600 is multiple of 20, you say, okay, 1 to 20, we have all remainders. These 20 cases, and last one to 600. In each box, 2 of them are good, okay? 4 and 15 mod 20. How many boxes are there? 600 over 20. In each box, 2 of them are good, so it will be 60. Now, this one, again, we can say same thing, 600 over 30 times 2. It will be what? It will be 40. Let's check. 2 times is 1,200. It will be 120 over 340. So the answer will be 60 plus 40 minus intersections. For this one, it will be 600 over 60. For each box, we have one good thing. So it will be 10 minus 10. And for this one, again, we can say same thing. 600 over 60 times 1, which is 10. Minus 10. So 100 minus 20, which is 80. Okay. Okay, if let's see how many ideas we considered. 6 ideas. If you want to learn more ideas, feel free. in combinatorics 4050 important ideas and formulas in combinatorics, algebra, number theory, and geometry. Feel free to send message to my WhatsApp number in the description. Thanks for watching this part.